Okay, so we all have a copy of the periodic chart. This is a must. This is the tool that we're going to use in order for us to learn how to name compounds. We are going to classify, if you look at your first handout, the different types of compounds depending on the nature of them. Do we remember in the periodic chart where the nonmetals are? I have a periodic chart up on the screen. Which ones are the nonmetals? We have a staircase. The staircase is someplace around here. And to the right of the staircase we have what? Nonmetals. And to the left are metals. Okay? So the very first category was those compounds formed in here by two nonmetals. Okay, so it was called binary compounds of two nonmetals. Binary means we're using simple compounds with only two elements, and both of these elements are nonmetals. Okay, so we started that category, and this is reviewing from last lecture. We are talking about covalent compounds of two nonmetals. And what we did was we picked a compound that we feel totally comfortable with, like, which one was it? What compound did we pick? CO2. CO2. And we learned how to name CO2 a long time ago. And by naming it, we are going to really elucidate the rules to name any other category, any other compound in that same category. So we're first naming the first element, carbon, C-A-R-B-O-N. Then we did not say carbon two oxygens, we said carbon what? Dioxide. So we're using Greek prefixes, and the di means two. Very good. And then the stem of the second nonmetal, so we didn't say oxygen, we just said ox, and then the ending is IDE. So we're dissecting what we did for CO2, and then we use the exact same rules, same set of rules for CO. So what would be the name for CO? Carbon monoxide. Very well. So now our prefix is changing. We're using Greek prefixes. Mono stands for one, di stands for two, tri stands for three, tetra stands for four, penta is five. This is only in this category when I have both elements being nonmetals on the right of that staircase. Hexa is 6, hepta is 7, octa is 8. These are all Greek prefixes, so we sound so sophisticated. Nona is 9, and we stop at deca, which is 10. So if I am to name CCl4, what's that name going to be? Carbon tetrachloride. So I have my ending IDE, just like I did in carbon monoxide, carbon dioxide, carbon tetrachloride. Everybody's ending in IDE. So my ending is IDE. Let's outline that ending. IDE, IDE, IDE. Okay. Dinitrogen pentoxide would be what? N2? N2O5. And sulfur tetrafluoride would be what? F4. And carbon disulfide would be CS2. So the very first thing we need to realize is that both the elements that we're dealing with are nonmetals. Problem is, we forget to classify. Okay, so the very first thing to do when we're doing nomenclature is first we classify, then we name, not the other way around. Okay? We moved on to category number 2, and in category number 2, we had salts. What section of the periodic chart are we in when we are addressing a compound like NaCl? Na is a what? metal. So now we're looking left of that staircase, and Cl is a nonmetal. So when we have a metal and a nonmetal, we're no longer in the binary compounds of two nonmetals. We are in a different category. We will use a different set of rules. And again, NaCl is a compound that you all know since way back. The name for NaCl is sodium chloride. So the first element, my metal, we first write the metals, then we write the nonmetals. And this is just done by convention. I heard my mom said that many, many years ago it was the other way around. Okay, but now it's first metals, Na, then the nonmetal, Cl, as opposed to Cl and A. First, we name the metal. Every letter of the element's name, S-O-D-I-U-M, is in there. No stem, no prefixes. And then the second element, which is the nonmetal, in this case, we just use the stem and the ending IDE. Okay, so at this point, we need to review oxidation numbers. Okay, so we go back to the periodic table, and you all have your own copy of the periodic table. Group 1A, what elements am I talking about in Group 1A? I'm talking about lithium, sodium, potassium, rubidium. Okay, we're in the right place. Cesium and so on. If they are going to combine with a nonmetal, which is the category that we're addressing, they will always have a +1 oxidation number. Oxidation number means bookkeeping of electrons, means sodium lost an electron. So did lithium, so did potassium, so did rubidium, if they bump into a nonmetal and form a compound. Okay, so this category is called salts. You have a cation, a positive ion like sodium ion, and an anion, a negative ion like a chloride ion. And to name these, we need to review step 1, oxidation numbers. Sodium is going to be a +1. What's going to be magnesium, calcium, strontium, barium? What are those? +2s. Okay, what about aluminum? And I have aluminum up here. Aluminum is a +3. Zinc is a +2. And cadmium is a +2. Okay, so in here I have aluminum. I'm going to maybe write a +3 in my chart, and the aluminum. A zinc, I'm going to write a +2, and in the cadmium I'm going to write a +2, and I forgot one. Silver. What's the oxidation number of silver? Silver is +1. So let me see if this lets me add silver. That's a +1. These are the oxidation numbers when these metals are combining with a nonmetal. If they are by themselves, if they are an element, the oxidation number would be 0. Okay, so sodium by itself, if it hasn't combined with anybody, oxidation number is 0. Meaning it didn't lose any electrons, it didn't gain any electrons. But if I am forming a salt, okay, so we're trying to learn the second category, which is a positive ion combining with a negative ion. And the metals that we have just reviewed, group 1, group 2, aluminum, zinc, cadmium, and silver. These are called fixed oxidation number metals. Okay, so the fixed oxidation number metals, I'm going to put in a grid, maybe, and I'm going to write them lithium plus, calcium +2, aluminum +3 in a grid. Now across this grid, I am going to write nonmetals that these positive cations are bumping into. So if my nonmetal belongs to group 7, what is the oxidation number of FClBrI? -1. Again, this is if they're just combining with a metal. Okay, their oxidation numbers will be changing in other cases. What about if I'm talking about oxygen, sulfur, selenium, tellurium? Group -2. What about nitrogen, phosphorus? They're -3. So write it in your chart, in your own copy of your periodic chart. And now we're going to write the formulas of these compounds, picking a fixed oxidation number metal like lithium and combining it with a fluoride ion. What would be the formula for this compound between Li plus and F minus? Okay, so you are going to write in your own grid LiF. No pluses, no minuses, just LiF. Okay? One sodium, which lost an electron, combined with one fluoride, which picked it up. They both achieved an octet, and we'll review this octet rule soon in a couple weeks. Give us a compound LiF. And what do we call this guy? Lithium what? Fluoride. So we name it just like we named sodium fluoride. Let's pretend that's an I. It's pretty awful. Lithium fluoride. Okay, what about if lithium decides to combine with oxygen? Remember the crisscross? Li2O. So the lithium that has an oxidation number of +1 combines with the oxygen that has an oxidation number of 2 minus or -2, and that 2 goes there and that 1 goes there. That's what we call the crisscrossing. And what is the name for this compound? Lithium oxide. Lithium oxide. Okay, so I don't say dilithium just because I have a 2 in the lithium. I do not use Greek prefixes because I am not dealing with the covalent compound of 2 nonmetals. Are we okay so far? Are you with me? Yep. Any questions? Okay, let's combine lithium with nitride. What would that formula be? Li3N, and the name would be lithium nitride, and you write it. My pen, it's not calibrated, it's really acting up, so you write it. Lithium nitride. Bottom line, the ending is still IDE. I haven't changed that from sodium chloride. So my guru is sodium chloride for this category. My guru for the first category was carbon dioxide. Okay, so keep your categories first very, very clear in your head. What about if calcium is going to combine with fluoride? What is the formula for that compound? CaF2. And the name for this compound would be what? Calcium. Calcium what? I hear it too. Fluoride. Okay, my ending hasn't changed. Calcium fluoride. I don't say calcium difluoride. I think last week people did squeeze those prefixes there, but by now we're good? Yes? Okay, one more. Let's just do calcium together with nitride. What would be the formula for this compound? Ca3N2, and the name calcium nitride. So my rule is, if my oxidation numbers for my metals are fixed, meaning if my metals belong to who? Who were they again? If my metals were, which metals are we talking about? Group 1A. Everybody in group 1A, like lithium, sodium, potassium, they're all going to be +1s. Group 2A, everybody in group 2A is going to be what? +2. And then I had a few others. Aluminum, which was a +3. Who else did I have? Zinc, which was a +2. Who else? Cadmium, which was a +2. And who else? Silver. Okay, so these guys never change. These guys, forever and ever, stay the same. Now, if I add to this category variable oxidation numbers. And I'm now in this handout, my fixed oxidation numbers are here. Okay, at the bottom of the category 2, salts, positive ions and negative ions, metals, when they're binary, meaning 2 elements, 1 metal and 1 nonmetal, period. Because we did go over polyatomic ions as well. If we have somebody that's not a fixed oxidation number metal, such as iron. If I am going to have an iron here, and it's a +3 combining with, who did I have up here? F minus 1. What would that compound be? Fe combining with an F minus 1. What do I write? Fe, F3. And what do I call this fellow? This is a new category. FeF3, I need to think, okay, if this is what came my way, FeF3, I need to do the reverse of the crisscrossing. So that 3 goes up there, like I had it up there. That 1 goes up there. Okay, so I'm thinking iron is a +3, F is a -1, and I call it iron Roman numeral 3 fluoride. So I am changing my naming rules because I am changing categories. If my metals are variable oxidation numbers, and now it is a variable oxidation number metal, I must specify what oxidation number it's using. And if it's using a +3, and that +3 came from that. So I do the reverse of the crisscrossing. Reverse, crisscross, and I name it. Okay, so let's do it again. If I am combining tin with O, and the formula is SNO, and we don't want to name until we first, what? Classify. Are these 2 nonmetals? Are they 2 nonmetals? Do we have a periodic chart out? Periodic chart.
No.
Tin is where? Tin is right there. There's my tin. Is that a nonmetal? I don't think so. Okay, so I cannot use dis and tris and monos. Those are out of the question. Okay? Then is tin a fixed oxidation number metal or a variable? So once I know it's a metal, I need to classify even more. Is he a fixed oxidation number or is he a variable? It's variable. So if it's variable, I must do the reverse of the crisscrossing before I name. And this is called thinking. This is what we need to do. Okay, so we go back to 1045 nomenclature, maybe. What is the oxidation number of oxygen? Did we have oxygen up here? Did we know oxygen 5 seconds ago? Okay, so if we knew oxygen 5 seconds ago, and we know that oxygen needs 2 electrons to have an octet, and it's in -2, and we only have 1 oxygen. Okay, so I'm saying, I don't know what the oxidation number of tin is. I'm calling it X. But I know that if I add a -2, the sum of the oxidation numbers is always 0. That's what we did when we had Na plus Cl minus. A +1 and a -1, we did it automatically. It was so simple we didn't even realize that's what we're doing. But we're still doing the same thing. So what's the oxidation number 10? The oxidation number 10 must be 2 plus. Oxidation numbers, you need to say a plus or a minus. Whether you own and have $2 million or whether you owe $2 million, it's not the same thing. So give me the plus, whether you have a deficit of electrons, or a minus, whether you have an excess of electrons. Okay, so oxidation numbers need a plus or a minus. Tin is +2. So how do I name this fellow? tin what? Roman numeral 2 because it's a variable oxidation number. And then what? Oxide. Yes? One more or enough? Okay. So let's do what we did last time. We look at in Module 5 in our homework, Exercise 6. Find me a compound on page 5-9, Exercise 6, that belongs to this category. 5-9, Exercise 6. I want a variable oxidation number metal combining with a non-metal. So I'm forcing myself to categorize. I don't just go A, B, C, D, E and name everybody. I just pick a category and name them. Okay, like who? Q as in queen. Let's check out Q as in queen. Very good. Tin 2 fluoride. Okay, so tin 2 fluoride. Tin 2 fluoride. What is the formula for tin 2 fluoride, guys? And if I'm in category 2, metals and non-metals, but my metal's variable, I have to look at tin being a +2, F being a what? A -1, and I crisscross. Do not name, do not write formulas if you don't classify, if you don't do your oxidation numbers. Tin fluoride is therefore what? NF2. So what am I saying? Whoops. I am saying that my tin oxidation number +2 is combining with 2 fluorides. I am combining it with 2 fluorides. Patience is a wonderful virtue. No quiere. I think I asked this class already. Is this, let's pretend we can erase. There you go. If there's anybody here that is experienced with a tablet PC and knows how to calibrate this thing, I'm all ears. So the oxidation numbers, the sum of the oxidation numbers and the metals and the non-metals has to add up to 0. Tin is a 2, and I add up 2 times a -1. Okay, because I have 2 fluorines there, and each fluorine is a -1. So my sum is indeed 0. So my tin is a +2, and each fluorine is a -1, and I have 2 fluorines. Okay, somebody had found another one in problem 6. Do one more. M like in mercury. Oh, mercury is a funky atom. So let me tell you the story of mercury. That's a good one. Mercury, it's a little bit different. Okay, so we're touring metals. The fixed oxidation numbers, we start with those. Group 1A, Group 2A, aluminum, zinc, cadmium, silver. These guys, we start there. And crisscross, crisscross, just name the metal, name the non-metal, ending in IDE. Mercury is a lonely ion. Think of mercury +1 as a lonely ion that needs to hang around with another mercury +1. So mercury +1, check this guy out, is Hg2 +2. Okay, so it's 2 mercuries +1 hooked at their hips. They are together. That's mercury 1. You cannot get them separated. Okay, so the example that you chose, example 6M, involves him. And I am combining him. They're talking mercury 1 oxide. Mercury 1, which is this fellow that I have, oxide. What's oxide? Oh, what? -2. Okay, so I am writing oxidation numbers first. Do not venture and start naming or writing if you don't do this. This is why test 2 is a disaster. Okay? Because we are not present in class. So I'm preaching to the choir. You guys are here, so you're going to get it right. So if I have this fellow, what do I write? Hg2. Oh, ya, se acabó. Okay? Moving on. Nomenclature. After we did salts, ionic metals and nonmetals, and we realized that group 1 was +1 and group 2 was +2 and aluminum +3 and zinc and cadmium and silver were fixed, we moved on to good old polyatomic ions. Oh no. Okay, so we pulled out our charts and we put a T and a 4 and a 3. Did I email you this? I think I did, yes? So I am back in my periodic chart, polyatomic ions. I am putting in my periodic chart, let me erase this, or not. And I am going to put a 4 maybe in this color. I am going to put a 4 starting here, phosphorus, can't see that color, so let's try that one. There, there, there. Phosphorus, arsenic, sulfur, selenium, tellurium. I am going to put a T here, and I am going to put a 3 here. What does the T and the 4 and the 3 stand for? Did you get those? Everybody got those? The T, the 4, and the 3. We did this last time. Yes? Huh? And in this handout, you have your 4s, your 3s, and your T's. Okay, so I go back to my polyatomic ions. Or not. Where I had my T, I'm going to put 3 oxygens. So in my boron, carbon, nitrogen, silicon, I put 3 oxygens. It's 3 oxygens, 3 oxygens. That's a 3. That's a 3. That's a 3. So the T stands for the 3. Where I have my 4, I put 4 oxygens. So I put a 4, and a 4, and a 4, and a 4, and a 4. And where I have my 3, and the chlorine, bromine, iodine, I put 3 oxygens. And then my oxidation numbers didn't change. Whatever I had above group 7 elements, chlorine, bromine, iodine, I had a -1 in there, didn't I? In my periodic chart? 10 minutes ago? 15 minutes ago? I still keep my -1. In oxygen, selenium, tellurium, I had a -2. I keep my -2. And in group 5 elements, P and AS, phosphorus and arsenic, I put a -3. So it's -1, -2, -3, and again -1, -2, -3 for my T. Okay, so I learned the ATE polyatomic ions. In the screen I have 12 ions, and these are all the ATE polyatomic ions, meaning ClO3 -1 is chlorate. So BrO3 -1 is bromate, IO3 -1 is iodate. Are you with me? Okay, so this is, somebody send me another cute little mnemotechnic rule to learn some ions, and I'll email you that one as well. But we first start learning this 12. Okay, so you need to know that phosphate is, what's phosphate? PO4, you need the charge. PO4 won't do it. PO4 minus 3. And what is nitrate? NO3 minus 1. And what's borate? BO3 minus 3. And what's silicate? SiO3 minus 2. Okay, so you make flashcards, and this is going to be time consuming. Okay? But it's going to be in every test. From test 2 and 3 and 4 and final, I'm not going to let you have a test without this. So be smart and do good on test 2 and 3 and 4 and 5, because you're going to learn this today. Go to PLTL, do whatever you need to do, get your study groups going. And then when you do move on, okay, so you're memorizing using the periodic chart, put the T, the 4, and the 3 where they belong. And you're memorizing the ATE polyatomic ions, and we did this last class. And then we said, after you do that, then you move down to the ITE. Okay, so in category 1, our ending was IDE. Now it's not. Now it's ATE, ITE. And ITE is formed from an ATE minus an oxygen. Okay, so if I remove 1 oxygen, sulfate minus 1 oxygen, and so instead of being SO4 minus 2 is what? SO3 minus 2. If nitrate is NO3 minus 1, what's nitrite? I knock out an oxygen. So instead of having 3 oxygens, I have 2. But the charge doesn't change. Are you with me? If phosphate was PO4 minus 3, was phosphite. Okay? And then you do your grits. You put your lithium together with SO4 minus 2. And you crisscross. And what do you get? Li what? 2 SO4. And what's the name? Lithium sulfate. I don't have to say lithium 1 because lithium is always a 1. If there was a variable oxidation number metal, I would have to do that. So if I'm combining this with aluminum, what would that compound be? Al 2, and then what? What do I need? Perfect. I need a parentheses. Very good. SO4, how many times? Okay. What about if I am combining it with PO3 minus 3? I'm combining it with this guy right here. That would be what? Li? Li how many times? 3. So I need to crisscross. And then PO3. And the name would be? It's the easiest category to memorize. After you memorize your polyatomic ion, just call the metal lithium, call the polyatomic ion phosphite. This guy is phosphite. Okay? What about the other way around? What is the name for this fellow? Aluminum phos quanto? Phite. Okay? Okay. Quick. What is the name for this guy? Okay, I am pretending I'm looking at exercise something. Sulfur trioxide. Sir, very good. Say that so loud and clear. Sulfur trioxide. Why? Because this is not an ion. Because I have 2 nonmetals, and this is a covalent compound, and this is what you need to do. You first classify, and if you have 2 nonmetals, okay, do not confuse this guy with this guy. What's this guy? This is a sulfite ion. Okay, so an ion is a charged species, positively charged plus 1 plus 2 plus 3, negatively charged, minus 1 minus 2 minus 3. Do not confuse compounds with ions. Okay, compounds are compounds, and ions are ions. Okay, find me another one in exercise 6. Like U, exercise 6U. They want me to name nickel to iodide. Okay, let's. Our first fellow with the iodines had what letter? What number?
2.
Okay, when I had my 3, what was this guy? This was called who? What's IO3 minus 1? This is an 8. Okay, so this is iodate. Okay, so we start with iodate because this is one of my 3s. 3 oxygens and a minus 1. Any group 7 fellow is a minus 1. Yes?
Yeah.
Are we okay there? Okay, so in the periodic chart, I had put a 3 here. I had put a 3 here, meaning 3 oxygens, and I had a minus 1 here. Okay, so this right here had a minus 1. So it's iodide with 3 oxygens and a minus 1. Okay, so I start there. I start there, knowing that iodate is IO3 minus 1. And I am thinking out loud. Let's pretend this scrolls. If this is iodate, what's iodite? IO2 minus 1. Actually, for the group 7, besides the iodates and the iodides, I also have what else, guys? IO4 minus 1. What's that? And what's IO minus 1? 1 under the ite is a what? A hypoite. 1 more than the 8 is a what? A per. Okay, so besides the 8s and the ites. Okay, so start, hopefully last week you got the T's, the 4s, and the 3s, because there's many more. Okay, but if you do the little pattern and think, okay, I have an iodide, but I know iodate. I must know IO3 minus 1. So what's iodide? Iodide is IO what? 2 minus 1. And what's nickel 2? Ni plus 2. So after you're done categorizing and figuring out what you're dealing with, you're looking at the guts of the compound, then you do your crisscrossing. And then it's what? Ni, parentheses, IO, don't hear you, IO2 with a 2 there. So that's how I do nomenclature and category 2. Yes, find me another one. Problem 6 in this category. Use polyatomic ions. H like in Henry. Copper 2 oxalate. Okay, oxalate. In this handout that I gave you, besides the T's and the 4s and the 3s, there's a half a dozen others that you need to memorize. I don't know any other little cute little pattern to show you. So for oxalate, you need to know this is oxalate. Permanganate, okay, so those guys are listed. Oxalate, hydroxides, dichromates, Cr2O7 minus 2. Okay, so you learn, if you are asked to learn every state in the United States, you probably go, I start with my southeast, then I go to my northwest, and I group it. I do one group at a time. So that's what we're doing. And for these guys, you just have to group them. They don't have a T or a 4 or a 3. But once you know that oxalate is C2O4, then you can name it. I'm combining oxalate with who? Which one was H? Copper 2. Okay, so copper 2 oxalate. Go ahead and give this guy a shot. And again, you can realize that the hard deal is knowing the polyatomic ions. You guys do it, and I'll answer the question because somebody's asking a question. Okay, so let's finish this one. How do I write this one? Copper 2 oxalate. So I know that oxalate is C2O4 minus 2, and copper 2 must be what? Copper plus 2. That Roman numeral 2 means it's copper plus 2. Are you with me? And once you've analyzed, I am in category 2. This is an ionic compound. It has a polyatomic ion. I know it. C2O4 minus 2. That's oxalate. And they're telling me that copper is using a plus 2. Then I just write it what? Cu what? C2. A 2 to 2 ratio is the same thing as a 1 to 1. So I don't write the 2's and the 2's. If this guy is losing 2 electrons, and this fellow is picking them both up, only 1 copper to 1 oxalate will do. Okay, so some of these guys are monogamous, some are not. Okay, the previous one, I needed 2 iodides for every nickel 2. Okay? And nobody here has a problem between compounds and ions. Right? We're good in there. We're good categorizing. Okay, can we move to category 3, the acids? Oh, you wanted 1. Which one? S like in Sam. Okay, you're ahead of me. And I'll try to answer your question, but we need to do acids first. You're in another category. Okay? I'm in category 3. And again, some of you have a lot of homework to do. Actually, a lot of you have a lot of homework to do. This is not an easy topic. I said this many times. Test 2 scares me. Okay? So category number, new page, acids. New page. Acids. Nomenclature. Okay? An ATE polyatomic ion like sulfate. Give me another ATE polyatomic ion. Phosphate is what? PO4. That's another one of the 4s, but the minus is what? Give me another one. What is this guy called? Nitrate, and it's a minus 1. ATE polyatomic ions can combine with H pluses. And when they do that, they form an acid, and those acids are going to end up in ick. So what would be the formula for the first one? And all I'm asking you to do is crisscross, 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 assuming oxidation numbers are clear. H2SO4, the name would be what? Sulfuric acid. What about the next one? H3PO4, and the name would be phosphoric acid. If you were my student in 1025, you know this, because I did the same thing in every test. I tested nomenclature. So you either learned it or you learned it. Those were your choices. But some of the teachers are not that way. What is the next example that I have up? HNO3, and it's another nitrate. So these are all ATE polyatomic ions, and they're all going to end up with ick. Okay, so an ATE polyatomic ion like sulfate ends up in sulfuric. Like phosphate ends up in phosphoric, and that this fellow would be what? Let's pretend you go there. Nitric acid. Okay? So, are we okay? If I ask you to tell me the formula for chloric acid, what do? You don't go straight to the formula, you do what? H plus and what? Cl cuánto? You pull out your chart. Where's Cl? Where's my 3? No, not 4. Cl was one of my, remember my periodic? Cl had a 3 and a minus 1. So it's ClO3 minus 1. Yes? Okay, so then I write it. What is it? HClO3. That's how we do this. We classify, we go baby steps. For ITE polyatomic ions, the acid is going to end in OUS. For example, who is, give me an ITE polyatomic ion. What is it? NO2 minus? Who's that guy? Minus 1. Who's that guy? Nitrite. Okay, so if I combine it with an H plus, what's my acid going to be? HNO2, and what is the name? Nitrous acid. Okay? What about if I ask you to give me chlorous acid? It's H plus with who? Okay, so you're thinking ClO3 minus 1 is chlorate. So I don't want a chlorate, I want a chlorite. I want a ClO2 minus 1. And then I crisscross and I get HClO2. So all I can do, I wish I could just pour everything in my head into yours. But I don't know how to do that. The only thing I can do is invent the T's and the 4's and the 3's. And this is all in Appendix 9 of your lab manual. This category is one at a time. That appendix is wonderful. Appendix 9, sorry, of your lab manual. Now, to answer your question, sir, before we run out of time, who was this guy? PO4 minus 3 is phosphate. Okay, so that's step 1. And that was last week's Thursday's lecture. I asked you over the weekend to learn your 8s. Phosphates, nitrates, sulfates, that's where we start. Okay? And those of you who did learn them were good. Those of you who didn't, you're going like, oh my God, get me out of here. Because it is a lot. It is a lot. Okay, I, at one time, was sitting on that side of the room and I wanted to run away too. But once you realize that this is not working, okay, once you realize that that's phosphate, and you say, okay, I am going to combine a phosphate with one H plus. Or maybe I want to combine it with two H pluses. I am not going to combine it with 3. So when I combine an H with a plus, with a PO4 minus 3, plus 1 minus 3 gives me -2. So this is a new polyatomic ion, HBO4, and it's no longer going to be a -3, it's a what? -2. Okay, so this is going to be new polyatomic ions. These are the funky. This is the hardest category. That's the one he wanted to know. Okay, so I'm answering his question. I was going too slow. What about if I take 2 H's for a phosphate? It's going to be H what? 2PO4, Okay, so now I have a -3 and a plus and another plus. So this fellow is a what? A -1. Do you understand what I'm doing? The phosphate has a -3. If that phosphate decides to mingle with an H+, it is now going to give me a new polyatomic ion, and this guy is called hydrogen phosphate. It's not the same. It's a different guy. It's a different polyatomic ion. But the way we learn it, the way our brain works, we learn something and then we add another layer to that. So what I'm asking you is to learn phosphate. If you don't learn PO4 -3, we're dead. So we need to know phosphate and then add an H+ to that phosphate and come up with hydrogen phosphate or dihydrogen phosphate. And then let's do our little grid. In our little grid, I am going to combine give me a metal. Give me a metal ion. Fixed or variable? What do we want? Variable? Okay, Fe plus 2. I'm going to combine that with HPO4 minus 2. And I am going to combine that with H2PO4 minus 1. Okay, so the same thing we did for NaCl. This is all started with NaCl. You go simple first. Your comfort zone's so great. And then you raise the bar. And start changing your metals to more challenging ones, or changing your anions to polyatomic ions. Now we are in acid salts. Acid salts. We're in acids, but you have a salt because you have a metal ion. So what would the formula for the first compound be? Fe, H, PO4. The problem is, I'm not going to give it to you like that. I'm giving you FeH, PO4. That's what I'm giving you. So you dissect, okay, HPO4 is this guy. This is where your head is going. And the Fe must be that guy. And then you name it. So what is that guy called? It's not called it's called iron 2 what? Hydrogen phosphate. Okay, so don't start in this category. This is category 4. This is the hardest category. You need to know category 2 really well and 3 really well before you go to category 4. Let's do it in here. What is this fellow's name? Formula, sorry. H2 parentheses. H2PO4 close parentheses and a 2. And what is the name for this guy? So you recognize this, your polyatomic ion being that, which is dihydrogen phosphate. And that 2 must come from here. Okay, so you do the grid. You do the reverse of the crisscrossing. This is what's given to you. And this is going to be iron 2 what? Dihydrogen. Are you with me? Now we can do the one you wanted, sir. Which one was the one you wanted? S like in Sam. Zinc hydrogen sulfite. Okay, so this is the way it comes. Zinc hydrogen sulfite. So you're thinking sulfate is SO4. This is your thoughts. It's SO4 minus 2, that's sulfate. That's step 1. I learned that Thursday, hopefully. Then from there I went to sulfite, which was SO3 what? Minus 2, and that was called sulfite. I learned that Friday. Assuming the 8s were in your head on Thursday, then Friday you got the ites in. And today you learned hydrogen sulfite. So who's HSO4, SH3 going to be? -1 charge. and he's hydrogen sulfide. So I am categorizing, and I am combining that with zinc. What's the oxidation number of zinc? +2. Okay, so fixed oxidation number metals, bottom of that handout, the first handout that I gave you, gotta go in your head. Cannot do this without knowing that. And then we crisscross, just like we crisscross everything else. So what do I call it? What do I write it? Zinc, and then parentheses, HSO3, close parentheses, 2. Not so bad? The good news is that category 5 is the easiest. Bases, we already did that because I squeezed that. My polyatomic ion is hydroxide. So if I ask you to give me the formula for zinc hydroxide, and this is as far as we're going to do, what are you going to think? Zinc is a zinc +2, right? Because I know that that doesn't change. And hydroxide is a OH -1. So what's the formula? Zn parentheses OH2. Okay, what about if I do it the other way around? If I ask you to tell me the name for Cu parentheses OH2, and before we answer, we think. Copper 2 hydroxide. So what are you doing? You're thinking hydroxide is an OH -1. Copper, that 2 goes up there. You're thinking oxidation numbers. So do lots of grits. On your column, start with lithium, sodium, potassium, calcium, aluminum. Start with the fixed. Zinc, silver. Then go move to copper +1, copper +2. Iron +3, iron +2. Tin +2, tin +4. And then across, start with fluoride, bromide, oxide, O -2, N -3, and then go with your polyatomic ions. And then go with your other ones. Okay, so this guy is copper. This is learnable, is my point. Copper, Roman numeral 2, hydroxide. Any questions?
You don't have any trick to learn the ions that have hydrogen, right? Like you had for the 4 and the T and the...
Those guys I don't have any trick. Well, the hydroxide I just made a category of it.
No, I mean the other ones.
The other ones, no. You gotta just, there's just 8 of them, or not that much. Okay? I learned them all without the 4 and the 3 and the T. Okay, so it can be done. That's my message. This is learnable. Have a wonderful day. I will talk to you later.